using the prior information. Okay, let's define claim frequency. Aggregated loss is the sum of these losses. Claim severity is the sample mean of these aggregate losses. We just divide the S over N to get the claim severity. And pure premium is aggregate loss divided by number of exposure units. So very simple. Number of claims N, sum of claims is the aggregate loss, claim severity is the average, and pure premium is aggregate loss divided by expected number of exposure units. These are four definitions. Also two more letters. I am here. Wonderful. This is just times M. Times M. Not the dot M, but times M. Okay, so we have these loss measures N, Xi, S, X bar, P. They are random variables determined by uncertain events. And while the exposure E is known as a constant measure and the size of the risk group, let's say we denote the predicted loss based on this manual M, and the observed value of losses based on recent data using the D, the risk group. Thus, M and D will refer to the predicted value and observed value of these N, S, X bar, and P. So we have the classical credibility approach. We just use the weighted average D and M, like we did here. This is like the weighted average, the classic credibility approach. And also there is another one, the credibility factor, which is denoted by Z, and we have to distinguish this factor. If the Z equals 1, we will achieve full credibility. If it is not equal to 1, this will be partial credibility. Okay, let's just use the example to show. So there we have the loss per worker, $230, and we have the parameter for credibility, 0.46, the risk group. What will be the predicted pure premium? So what we have from this task, let us define the variables we have. Example 4. Pay attention to these examples, because next time you are going to solve tasks according to this lecture. Okay, so what we have? We have D equals to 230, and we have the M equals to 292. And Z we have 0.46. 0.46. So what can we calculate? We can calculate the pure premium. So we are using this thing, using this formula. with the credibility factor, so ZD plus 1 minus ZM. Okay, ZD plus 1 minus ZM. So 0. This Z D plus 1 minus Z times M. So what we'll have in the end? In the end, we will have U of $263.48. $263.48. So next year the company will charge this amount of premium instead of 230. Amount will be charged next year. So U is always the experience measure D and the manual rate M. The closer Z factor to 1, the closer the updated predicted value U to the observed value D. Okay. So Z can be distinguished as relative importance of the data. So if Z equals 1, then we just stick with the D. If Z closer to 0, then we stick to M. So 0.46 is somewhere between 230 and 292, so we got this partial credibility. If we have large data set, the larger the data set, the larger will be the credibility. Okay, let's then start with the full credibility. We have the random variable n and mean and variance, mu n and variance sigma n. What will be the, how likely will be the n as the representative of true mean? What is the probability of observing claim frequency within this 100k% of the mean? So this is like the general question for many tasks, and we are going to answer this question using this formula. So this factor, the k percentage of mu over sigma, will be the that value. This is the percentile, 100k percent percentile of the standard normal distribution. Generally, we need this alpha value to solve tasks. So k over sigma equals to z.